Hey everyone, my name is Fiston Ngabonziza, and today I'll be representing my research on the dose-dependent effects of vitamin C on A549 lung cancer cells. So, vitamin C is known for its redox modulating properties and has been studied for its potential therapeutic role in cancer treatment. It influences cell culture processes such as reactive oxygen species, generations, collagen synthesis, and apoptosis. So my study aimed at the vitamin C induces those dependent cytotoxic effects and apoptosis in A549 cells. And my objective was to evaluate the effects of vitamin C on cell availability, apoptosis, and collagen modulation in A549 cells. So my methods included that I conducted for this research was A549 cells, and they were cultured under standard conditions and treated with vitamin C at varying concentrations for 24 hours. I utilized several assays to assess the compound's effect. So for cell availability, I was measured through the MTT assay, and the apoptotic activity was quantified using the apoptosis assay. And I also did the PCR analysis to examine the collagen gene expression as a key marker for collagen synthesis. Yeah, as you can see, these are the methods that I did. So I went ahead and did my findings, and these were my results for the effects of the treatment of A549 cells cell availability assessed by the MTT assays. So my findings were intriguing. First, the MTT assay revealed a dose and time dependent reduction in cell availability, while the effects were mild at 24 hours. For lower doses, higher concentrations significantly reduced availability. So by 72 hours, cell availability at highest doses dropped around 30%, showcasing the potent cytotoxic effects with prolonged exposure. So secondly, I did my dose-dependent induction of the apoptosis of vitamin C in A549 lung cancer cells. So the effects of the vitamin C treatment of apoptosis assay was represented by the graph here and the images, as you can see. Yeah, so the apoptosis assay showed that the vitamin C induces apoptosis in A549 cells dependent responsive manner with a significant apoptotic activity observed even at the lower doses. For instance, the apoptotic increased from 10.10 at my lowest dose and also increased at 16.10 at my highest dose, confirming that its potential as an anti-cancer content. Finally, I did my PCR for my gene expression analysis, and the untreated group showed a baseline expression level at 1.0, and my lowest dose showed resulted in a one point in an expression of 2.7, while my highest dose revealed an expression of 2.96. Although there was no apparent dose-dependent upregulation of my gene, the difference was not statistically significant, which makes me conclude my study by saying it demonstrated that the vitamin C reduced cell availability and induced apoptosis in A549 cells in the doses and the time-dependent manner. Cytotoxic effects were significantly uh, at a concentration of greater than or equals 4.0 microgram per mil after the 24 hours and intensified the prolonged exposure with apoptosis markedly increased at 0.5 and 5 concentration doses. Additionally, vitamin C exhibited the complex effects and collagen synthesis, suggesting that the roles in cellular system. So the future directions would be that the future studies should focus on unveiling the mechanism behind the vitamin C, particularly its roles in ROS generation and mitochondrial dysfunction. So protein levels analysis such as Western blotting could clarify its effects on apoptotic markers. Extending treatment duration may reveal sustained impacts on collagen synthesis and cell availability, investigating the selective for cancer virus normal cells and employing more precise collagen detection methods. Finally, these were my references, and I would like to express my gratitude to Dr. Jessica Livingston, Marla Mackenzie, Shanda, and Dr. Michael Gibson for their guidance and support through the research project. Thank you so much.